Some properties of exponents. Number one, product rule. When we have product of same base, x raised to m, x raised to n, then we add the exponents, m plus n. Something like when we multiply x square and let's say x cube, then this will be just x raised to 2 plus 3, that's 5. Okay, this is not equal to x raised to 6. We just add the exponents. Okay, and next, by the way, one more thing. When we are asked to add x square and x cube, plus means these are unlike terms. We cannot add or subtract, just this is it. But when we multiply, then we add the exponents like this. Similar, quotient rule. When they are in fraction, then m on the top minus n. Something like if you have, let's say, x5 over x2, then we got same base x, this is 5 minus 2, and that is x3. Or you can think of, okay, 2 copies on the bottom, 5 copies on the top, 2 copies cancel, 3 copies left on the top, same thing. Now negative exponent. So we don't like to write negative exponent. So x raised to negative m, that is just 1 over xm. Okay, let me combine two examples here. Suppose we have got x square over, let's say, x4. Then we can move up using the quotient rule, x just x. 2 minus 4, that's negative 2. But we don't like negative exponent in this way, so from this negative exponent rule, we can just write 1 over x squared. Okay, or we can think this as, okay, since we saw higher exponent on the bottom, instead of moving 4 to the top, we can move 2 to the bottom. So x squared to the bottom, that means nothing left on the top, means 1 over x raised to 4 minus 2, which is 2. So 1 over x squared. So we get the same result. Okay. Now the next rule is power rule. Okay, when we have x raised to m and everything raised to n, we multiply these two exponents, m times n, like x squared raised to 3, then we multiply. Okay, look at here, when we have x squared times x cube, we add the exponents, 2 plus 3, 5. But when we have like this, x squared cube, then we multiply x raised to 2 times 3, 6. Okay. Now fractional exponent rule. Sometimes it's useful to write in terms of nth root of something or fractional. So we can write in this way, sometimes we write this way. It depends. Okay, but in calculus, you can write either way. Let me show you an example. We know when we have x raised to 1/2, that's the square root of x. This is pretty much, this 2 on the bottom is here, the power of root. Okay, square root of x raised to 1. And this is already square root, so we don't write 2. That's the tradition, not to write 2. So square root, x raised to x is just x. X raised to 1 is x. So x raised to 1/2 is just root x. Suppose we have, like, let's say x raised to 2/3. Then that is in fact, okay, this is 3 on the bottom, so cube root of x squared. Okay, this is how it works. Now zero exponent rule, somehow a number raised to 0, that is 1, and this number a should not be equal to 0. 0 raised to 0, we have no idea. Like 5 raised to 0 is 1. When we write just 5, this is in fact 5 raised to 1. But somehow, if we get like 5 raised to 0 or 10 raised to 0, 2 raised to 0, then that's 1. We can think of this in this way. Let's say 5 over 5. 5 means 5 raised to 1. 5 raised to 1, and we have 5 5 same base 5 1 move up 1, so 1 minus 1, 5 raised to 0, and that's 1. Or simply this is just 5 over 5, right? Then when we divide 5 by 5, that's 1. So either way it works. But if you end up getting somehow like 5 raised to 0 or number raised to 0 or some, that's 1. And power of product rule. Suppose we have x times y, okay, raised to m, or x divided by y raised to m. It will be, if it's a product, it will be product. If it is quotient, then power of quotient rule, that will be quotient as well. Okay, so power of product means when it's times, it will be times. Power of quotient, that when we have fraction, then we have fraction. Let me show you some examples. Like when we have, let's say, let me combine a couple of things. X squared y cubed raised to 5. Somehow we are given this to simplify. Then it's a times. So we multiply 5 times 2 and 5 times 3. So x raised to 10 times y raised to 15. In the same way, suppose we got, let's say, x squared over y to the negative 3 raised to 2. And if we are asked to simplify, on the top, x raised to 2 times 2, 4. On the bottom, y raised to negative 3 times 2, negative 6. And we don't like negative exponents, so y raised to negative 6, we can move up, but they are unlike base. I mean, x and y are different, so x to the 4th on the top, already there. Move this up to get rid of negative exponent, we get y to the 6. That's the final. Okay. Let me do a couple of examples. Sometimes we end up getting like a lot of times x times square root of x, and we want to combine this. This is x means x raised to 1 times x raised to 1/2. Now using the product rule, we got same x, 1 plus 1/2. 1 is 2 halves plus 1/2, 3 halves. We may live here, or this is in fact square root. Look at the 2 on the bottom. That is square root. Here is 2. That we don't write. X cube. Square root of x cube. So x times root x will be like this. And a lot of times we get the other way around. Like we have to simplify square root of 8. Okay, that is in fact you can do a square root of 8 is you can do 2 times 4. Okay, and that is, this is 2 squared, and or we know square root of 4, that is 2, and root 2. These are coming from the rules of exponents, but we always skip a lot of steps, and we get square root of 8 being 2 root 2. Okay, and if you are asked to add like root 2 plus root 3, no, you cannot add. This is it. These are unlike terms. That's it. But if you are to multiply square root 2 times square root of 3, okay, this times means now you can multiply square root of 6. Okay, final.